Good morning, good afternoon, good evening, everyone, depending where you are on the globe. Welcome to the March edition of tinyML Trailblazer series. This is our monthly series. tinyML Trailblazers is the place where you're going to meet key people, tinyML masterminds, mavericks who drive this industry, this technology forward. And it is a pleasure to celebrate Qeexo success story today, and the success story of its co-founder and CEO, San-Won Lee. Qeexo has been around for quite some time. In fact, Qeexo is one of the pioneers in tinyML. The company was founded in about 10 years ago, more than 10 years ago, in 2012. And since then, they've been doing a lot of cool things in the sensor, ML, tinyML space. In fact, they're probably one of the most successful in terms of volume, as far as I understand from talking to San and his colleagues. They've been deploying tinyML solutions in more than 300 million devices since they started the company. So that's a very impressive number. And recently, Qeexo entered in a partnership with TDK, and that's obviously something that is going to take the company to the next step, and that's something what we'll discuss today here. Again, welcome, and it's going to be very interesting, inspiring, educational, and illuminating. As usual, before we start, it is my pleasure to acknowledge tinyML strategic partners and sponsors, also the companies who make this series and tinyML events possible, specifically AZIP, AI, Analog Devices, Adrena, ARM, Compass Marketing, Edge Impulse, Greenwave Technologies, Gravity Inc., IBM, Magimob, Inotera, it's a new strategic partner, Microsoft, Nota AI, NXP, OctaML, Pollen Technology also joined recently. Qeexo, that's the company that San founded or co-founded. Qualcomm, Renaissance, Schneider Electric, SensiML, Sony, Silicon Labs, ST Microelectronics, Synaptics, Intel, and TDK. A couple of announcements, so all you know that tinyML communities are growing really fast, so you are very welcome to join these communities and enjoy all the resources and communications that happen there. This presentation is going to be available on tinyML YouTube channel that has close to 9,000 subscribers and a lot of material, more than 5,000 videos. And a lot of views there. So again, you're very welcome to join by clicking this QR code. A couple of really exciting announcements. In less than a month, we have tinyML Summit coming. This is our annual flagship event. It's going to happen here in the Bay Area, and it's going to be in person. We are very excited about this event. So you can go to the website and register. And on day one, on March 27, we'll be holding a third tinyML Research Symposium, which is also going to be quite exciting to see the latest and greatest in the academic world, in the research world. So again, if you happen to be in the area, or if you plan to join this event, registration is open, and it's going to be a really interesting event focusing on end users and applications of tinyML, and obviously also on the technology and all the innovations there. Another very exciting event coming up is tinyML EMEA Innovation Forum. It's going to take place in Amsterdam in the end of June, also in-person event. And I think call to presentation is still open. I think it just the due date was actually yesterday, but you still may probably submit your application, and there are sponsorships available. So definitely, if you're located in Europe or Middle East and Africa, this will be the event to attend in June. Also going to be a very interesting event, also focusing on the innovations and applications of tinyML. Before this, actually in a week time frame, we'll have a very strong presence at the Embedded World. That's a big exhibition highlighting all the technologies and products and innovations in the embedded world. That's what it's called. tinyML Foundation is going to have a pavilion, dedicated pavilion with 9 companies joining the pavilion, and there will be dedicated technical sessions and tutorial there. So it's going to be another exciting event with more than 20,000 people attending typically a year. So yeah, we are very excited. And at this point, it is my pleasure and a privilege to introduce our host. It's Dr. Chris Rowan. Chris is very well known in the tinyML world, in the high-tech world, in the high-tech entrepreneurship world. He's been around for quite some years after his graduation from Stanford and Harvard in the 80s, and then he's been creating a lot of interesting technology innovations and companies. Some quite successful of them, like tensilica is very well known in the community, and several startups. One of them, tinyML startup, Bubble Labs, was acquired by Cisco a little bit over 2 years ago. And that's where Chris is today, leading a machine learning group there at Cisco. And again, we're very fortunate to have Chris here as the host. And Chris, the stage is yours.
Thank you so much. It's a pleasure to be here. And it's a particular pleasure to introduce Sangwon Lee. He is the CEO of Qeexo and co-founded the company in 2012. He has a long history, even before Qeexo, where he was at Samsung and SK Telecom and HTC. He really has been at the heart of tinyML, really working at what is the infrastructure, what is the programming model, how do you integrate sensors with machine learning capability. And so I think his story and the story of Qeexo and the story of sensors and the story of machine learning infrastructure for edge applications is really right at the heart of what we're all trying to do in the tinyML community. So welcome, Sang.
Thank you.
So perhaps the best place to start is a little bit of the history. What's the story of how you started Qeexo? What did Qeexo focus on initially? How did you evolve to the current product? And where are you now, especially now that you're just going through this transition of after having been acquired by TDK 2 months ago or less?
Okay. Yeah, I'll try to put it in a concise way as possible, but it's a long story because I started the company 2012, so it's been over 10 years. So there was a lot of up and downs, and a few challenges that we had to overcome. And from where do I start? Okay, so I first met my partner and co-founder Chris Harrison, who's our CTO at Qeexo, in 2011, end of 2011. He was a PhD student at Carnegie Mellon University doing the research in human-computer interaction field, and I was at HTC up in Seattle, actually in Bellevue, doing technology program management, which was going out and scouting new interesting technologies. And my field of expertise, or my domain at the time, was user interaction. So I got to meet Chris through his website. Actually, I randomly ran into his website, saw a lot of new things that he was doing, and there was a lot of interesting technology that I thought could be applicable in mobile space. So I reached out and and we decided to start up a company that builds interesting user interaction technologies for touchscreen devices. So that was our first idea of starting Qeexo. And once we started the company, we were targeting to commercialize this technology called solution. Actually, it's a solution called FingerSense. It's a solution that allows conventional touchscreen devices to understand different type of input. So, we're very used to using this multi-touch, capacitive touch device called smartphones. And but in terms of interaction method or the input type, there's only one input type that we use, which is our skin capacitance. And so when you touch the screen, the screen immediately registers XY coordinate. And what we wanted to do was we wanted to add a new input dimension so that the applications will now see X, Y, and type, not just XY coordinate. And we wanted to do this in a very clever way of using machine learning and sensor data. And specifically, we're using the vibration sensor and capacitive sensor to classify different parts of the finger as an input type. Back then, in 2012, we didn't really have a concept of this tinyML. When we first built the prototype, everything was running on the AP on the smartphones. But when we started to pitch our solution to smartphone manufacturers, we were getting these requirements from smartphone manufacturers, and a lot of the requirements basically challenged us to come up with this solution that can run on a small microcontroller. Because as you can imagine, on a smartphone device, power consumption is a very high requirement, a very strict requirement too. So as FingerSense needs to run constantly when the screen is on, the power consumption requirement and also the latency requirement and the accuracy requirements that we needed to meet, basically gave us this, I guess, the challenge to evolve the solution that can run on a very small microcontroller. So, the productization, I guess, the productization process pushed us to the limit where we were able to, do our engineering to compress the models and figuring out how we can run things on, microcontrollers with Cortex M0 and M4, so that we can meet all those requirements. And, it took us about 2.5 years to get to the market. So we first commercialized the solution with Huawei in 2015, April. And from there until mid of 2019, when we actually had this pivot to start Qeexo AutoML, there were a lot of different projects that we did with Huawei. We commercialized over 260 different models with Huawei, selling over 300 million units. But getting to that point, it was a different, building the solution was one problem, but getting to that scalability was really the big challenge. So I think, and I'll get to the story of what we do today, which is Qeexo AutoML, the automated platform that allows users to build tiny machine learning models without writing code. And this really started from that interactions with device manufacturers, because I think a lot of people here probably are going through the same stage when building machine learning models and finding that building machine learning model is already very challenging. And if you want to build something that can run on a small microcontroller, obviously it's even more challenging. But building the solution is just one part of the problem in productization, I guess. Because when we first built it, Huawei loved it, and that was all great. But then doing the optimization, model optimization for one specific smartphone model took us about 2 months everybody living in China, doing the data collection and training and testing and going through that iteration over and over again to get to the commercial level. It took us a lot of efforts. But then Huawei had many different models that they launch every year. So it wasn't just one model that they launch it, every year. So they asked us that, hey, they like the solution a lot, and they want us to build models, optimized models for 60 different models every year. So that's when really struck us, struck our head that hey, building the solution, we were successful in doing that, but how are we going to scale? How are we actually going to support all these different models? And that was a bigger problem, right? So naturally, we looked into start building automation tool, doing data collection, building models, and we needed to build a solution that even non-machine learning engineers can use to support customers. So we wanted to make it as simple as possible, because for us to scale, back in 2015, I mean, even now, hiring machine learning engineers is not easy. It's very difficult, and trying to find somebody in China at the time was even more difficult. So we need to make sure that, hey, if we were going to really scale at this level, then we need to have a tool that even non-engineers can utilize and work with the customer. So that started our engineering efforts in building this automation tool. And then by 2019, we were already launching more than one model per week. So we're supporting more than 60 models a year. And that's how we got to 260 models within the 4 years.
It really gets at a critical question in the life history of startups, because generally speaking, startups that start horizontal have trouble getting even customer number one. So they have to go figure out somebody's more complete problem that you're solving. And in the case for you, it was touch sensors and Huawei. And often you then sort of say, well, now I need to find another customer and another customer, another customer like that in order to build the business. In a sense, the breadth of Huawei's product line provided that breadth that you needed and introduced you to the question of, well, how do you really scale? And so you had an unusually smooth path from the necessity of being vertical to the vision of being horizontal. But clearly, you then have to go beyond the particular characteristics of one customer. There is not just the difference now from one model to the next, but how these different customers do business and which problems they're trying to solve. How did you figure out which dimensions of horizontalness and which dimensions of verticalness you would really focus on? Where did you say, yeah, we can cover that? And where did you say, no, that's not our, that's not a dimension in which we play?
Good question.
For example, I would imagine you didn't say, no, you didn't say, yeah, we can do it in the cloud too.
Yeah, good question. So at the time when we were, focusing on smartphone market, building applications for smartphone market, our main business model was IP licensing model. So we were coming up with our own solution, the fully packaged solution, and licensing it to device manufacturers. So it was more the market requirements in the productization was still coming from the customers, but the actual idea, the application idea, was developed in-house. So it wasn't much about asking the customers about what the problems that they're facing or building custom solutions for them. So back then, that was our main focus. But since then, since 2019, when we pivot to this SaaS model, machine learning as a service on running on cloud, this that was when we were really thinking about, okay, this tool can actually serve more variety of customers who want to build their own application. Because around that time frame, like 2018, 2019, that was when we were starting to get this request from different customers asking us to build them custom applications, like custom machine learning models. But we weren't in the consulting service business, so, and we weren't really interested in building custom applications for different customers. We wanted to build something that we can, utilize over and over again. So, we were naturally just pushing away those opportunities. And then, that's when we found that, hey, wait a minute, like we already have this tool that our field engineers can use to build our own applications. Why can't we just repackage this into a serviceable platform so that other customers can build applications themselves? Because oftentimes, when we meet the customers, even today, customers that are not, experienced in machine learning application development or have experience in working with an AI company, often misunderstands what we can do for them, because they think that, hey, AI company can show up and suddenly present a ready-made solution that will work for you from day one. But obviously it doesn't work that way, because we're AI experts, but we don't have the domain expertise in industrial space or automobile space. So there's that learning process that both parties need to go through. So what we wanted to do was, hey, if we can build a tool and then start educating the customers how to use a tool, then they can build the applications on their own. So that was the big motivation to build Qeexo AutoML service. So today we work with the customers, and we start with we do go through that stage where we want to go and discover the problems with the customers, and then start providing the solution and the tool so that they can scale. But we won't be able to do that for everybody. So today we have a focus area in industrial space. So our focus today is to help customers in the industrial space that are going through the digital transformation, and that's where we see the opportunity that we think that our tool can provide the most value. We do have things where limitations to our tool. Right now we're focusing on building the models that can run on the sensor node, like for example, like sensor driver chip level, and we support mostly the time series sensors. There had been a lot of questions about, hey, can Qeexo support image processing and doing the deep learning models that runs on the cloud? Yes, we can, but we need to focus. We need to have a focus. We can't do everything. So we decided that, hey, our focus is going to be building tinyML models in the industrial space.
And what have you found in practice as the sweet spot in terms of what functions people need, which verticals, which kinds of applications tend to be the ones that fit best into your model? People get the most confidence because of the completeness of your familiarity with the field.
Mm-hmm.
Where do they go? What particularly appeals? Which class of application particularly find you?
Well, so we do. We find that this tinyML applications work well in the common problems like condition monitoring of machines, or eventually doing predictive maintenance for machines that are running in the factory. And the reason why I think that tinyML has advantage in these applications is that in order to do a good condition monitoring, like very sophisticated models that can really detect the subtle difference of these machines, you do need to have the sensors to run at very high sampling rate, and you do need to have many sensors attached to the machine running all at the same time. Now, oftentimes, we run into these situations where customers say, hey, we did try to prepare for this, and we had sensors attached to the machines running on the machines for many years. And can you take a look at the data and see what you can do with it? But oftentimes in those kind of situations, without really knowing what type of sensors to use or what type of sensor configurations to use, people typically set the sampling rates and sensor configurations to meet the other IT requirements, like bandwidth requirements or storage requirements. So sampling rate had been a common problem, that most of the times the sensors are running at such a low sampling rate that it doesn't really provide much of information there, or they've been just using the sensors to do set some kind of a threshold, so that if a sensor detects any kind of situation that goes over the certain threshold, it just stops the machine, but it's not really doing any kind of intelligent interpretation of the situation. So tinyML can really solve this problem well, because we're running models right on the sensor node. You're interpreting all the sensor data, so you're only sending the inference results, so that you don't have to worry about the bandwidth, network bandwidth. You don't have to worry about or you don't have to worry too much about the storage, and also the power consumption. In case that you need to run the modules with a battery power model, then the running it on the MCU versus sending all the raw data to cloud, obviously you save a lot of power. So we find that this is a good opportunity for us. So that's where we focus today.
Yeah. I'm curious how you would characterize the level of sophistication needed for customers to take advantage of your tool. On one hand, if they know everything about building their own models, they don't need you. On the other hand, if they know absolutely nothing, they can spell AI, and that is that's probably not enough to so what is that sweet spot? Can you characterize what's the
question?
The typical or the ideal knowledge level for someone to be able to use it, but also to value what you're bringing to the party?
Very good question, because you're right. The customers their sophistication level of sophistication varies a lot. It's night and day difference. Right now we have two different business models. So we have Qeexo AutoML that runs on the cloud. It's it's kind of like Adobe Photoshop model, where you just come and sign up, and as long as you have the Pro Tier license, then you can build the models and build it and use it for your commercial deployment. In that case, the SaaS platform model works for customers that already has or have machine learning engineering experience. They already have the team, they already know what to do, but they want to use a tool to improve their productivity. Just like how we did back in the days when we were supporting smartphone manufacturers. Our team were using this tool to shorten the iteration cycle, right? So this is for those people that already knows how to do it, they can just license the tool and use it. And we do have customers that are using this as their main engineering tool. For those customers that are not familiar with machine learning, very introductory level of understanding, what we do is we typically engage in a full machine learning solution development terms, where Qeexo will go in and analyze the environment, build a full solution for the customer. But then we don't get involved in the mass deployment phase. So what we do is, after we build a solution for one reference environment, we train the customers to use our tool. So the field engineers can actually carry our tool to build optimized models for each new environment, if that is what's needed in the field. So it's kind of a two-step process, where we have to go in and build a solution and show them how to do it, and then train them on how to use the tool.
Okay, great. So what's the impact of being part of TDK? What additional opportunities does that create for you, and how do you start to exploit the linkage to all of that sensor know-how and sensor relationships?
Okay. Yeah. So the fit that we see and the synergy that we can create with TDK is that the sensor know-hows really. I mean, we have been working with sensors for many years, since the beginning of the Qeexo, but we're not a hardware. We don't build our own hardware, and we don't have sensor experts in-house. We're the AI experts that utilize sensor data, but knowing how the sensor actually works in more detail does help us in building a better solution, more robust solution, and also having the hardware, hardware as part of the solution package, that it gives a better opportunities to win customers, because there are customers in the industrial space that are searching for fully packaged solution with the hardware, not just AI. Because when we were by ourselves, we had to go in and sell AI solution, but still have to tell them, hey, you need to go and purchase the sensor from somebody else, and that's just more cumbersome process for the customer. So bundling everything in and building a fully packaged product for customers is a more convenient way of doing business for us. So that really helps too. And then of course the brand and the sales channel and the connection with industrial space customers, that's a big plus for us.
Yeah, I can imagine. Along the way, every entrepreneur, every engineer for that matter, but every entrepreneur faces some big setback. You hit some brick wall. And you pick yourself up and you go, okay, I learned something from that. Go on in some new direction. Can you give us some story of how in this Qeexo experience you faced some roadblock, found a way around it, and moved on?
Yeah, well, I have too many.
Oh, so you're a good entrepreneur.
Oh, I mean, it's 10 years, so a lot of ups and downs. In the beginning, there were a lot of challenges in coming up with a commercially viable solution. We've done many different POC projects with big brand device manufacturers in the mobile space, and that challenged us to improve our solution. And that first 2.5 years until getting to the first commercial launch, that was really challenging. But I think the biggest challenge was in 2019, mid of 2019, when our major customer Huawei got listed on entity list, and we had to stop working with them. And you can imagine Huawei was actually doing very well at the time. Their volume was growing, and they were really right up there with competing with Samsung and Apple in terms of the volume. And then we have to comply with obviously the U.S. government policies. So that was a huge challenge for us. But luckily for us, we did have this idea of starting this new SaaS business, and we had this idea since 2018. So we were slowly making those changes internally, coming up with the plan to pivot and build this platform business. So in 2019, when there was that announcement of Huawei being in the entity list, it was a decision that was made for us that, okay, now is the time. We can't wait any longer. So we made that pivot, and obviously everybody faced the COVID challenge, and we also did the COVID challenge. We were able to, working as a team and building the plan early on, that helped us to make those pivot, because it wasn't really a panic for us when Huawei was listed, because we knew that we just need to execute the next step.
Mm-hmm. So what comes next? What do you see, first of all, in the industry and in the technology that's going to change the game again? And then what do you think are the most interesting problems to pursue? What are the hard problems that your customers continue to have where you think you may be able to bring some energy and some light?
Yeah, I think in this, tinyML or AI in the industrial space, at least, that's where we focus today. So, I'll just speak, from that experience and how we see the market. There's still, a lot of different challenges that we see in the future regarding the mass deployment of machine learning models in the field, because building machine learning models, again, is just one part of the problem. The mass deployment does require different type of skill sets and different type of tools, and also it does take a significant effort to understand that each application, how each application should be designed. And you can imagine industrial space that every application is different. There's no company that has the same type of needs. Like, machines are all different, and it does require a lot of customization work. So there needs to be a good way to, or more efficient way to do field optimization. I think that's really going to be the key in the mass adoption of tinyML models in the industrial space. It'll be extremely difficult for somebody to come up with a universal model that can work on any type of environment. As machine learning, the way the machine learning works, the quality of machine learning solution heavily depends on the quality of data. So whenever there's a drift in the data, it will always affect the accuracy. So if you want to have the top-notch accuracy, then you do need to go through that final stage where you do optimization for each new environment. And I think that's where the challenge comes in terms of the mass adoption. So next stage, I think, whoever solves this problem. I mean, we're trying to solve that problem with Qeexo AutoML, but Qeexo AutoML is not solving every problem in the mass adoption. We do need to, or we are planning to, add more functionalities that will ease the pain for the field adoption stage. But there's still some work to be done.
Yeah, it seems particularly interesting in these areas where you have a sensor going into an application where the sensor may be the same, but the environment may be completely different from one installation to the next. And you really would ideally like to have a sensor system that works for what that one sensor is going to see, sort of some sort of a self-learning mechanism, and lots of preventative maintenance concepts build on that. But even that is kind of dangerous. You sort of say, well, this bus always runs the number 4 route, and the number 4 route has certain vibrations and potholes, and so we really should build it. But then what happens if the other bus breaks down and suddenly we put this bus on route number 8? Well, its training is no longer relevant.
Yeah, so you're right.
You gotta have this question of, well, I'd like to adapt it to the data, but I don't really know if the data is going to go through some fundamental phase change in a perfectly benign way. The fact that the bus was to route number 8 is not should not be reported, because now we have potholes in different places. So how do you think about the degree of adaptation where you'd like it to simultaneously be very specific to an environment, so you can find small outliers, small deviations, but also be very adaptable to the normal patterns that may occur in long time periods. Well, how do you think about that question?
So obviously it all depends on the type of application, right? And the variety of the different environments that they need to run on. So I don't think there's like one answer to this question, but to give you an example of FingerSense, the way we design FingerSense for smartphones. Obviously, for smartphones, this is a solution that needs to work right out of the box without any calibration, and user can immediately use their fingertip and knuckle as two different input type. And every human being have a different shape of their fingertip and knuckle, and the rigidness of their knuckle, or the way they're knocking on the device. The strength of the impact is going to be different. So when we designed FingerSense, we had this concept of sensitivity calibration. So the model can actually adapt to the user, but it's not actually change the whole model. It's just calibrating the sensitivity. So it was easier for us to do it that way, because it doesn't require users to provide their training data and retraining the model, because obviously going through that stage is going to be so difficult for users that no one's actually going to use that. So we built a model that's more collecting data from a variety of people, and then utilizing that data, we built a master model, and then we had a sensitivity calibration method built in. For industrial space, I think, because depending on the application, sometimes accuracy could be a very critical thing, and they would spend the effort to optimize model for each new environment to make sure that they reach the optimum accuracy. And doing that, we can use like the tools like Qeexo AutoML to speed up the process to optimize the model. But other way that we're designing, or we have in mind, is utilizing the sample data to optimize or recalibrate or retrain the master model, but doing it in a clever way where you don't actually need to collect full set of new data, but more like example data that can be used as a reference to augment the data set that we collect from a different environment. So you can better match the new environment. And so that's another way. But again, it's every case is very different. Some customers are okay with maybe okay with like 90% accuracy, but for some customers, like mobile device, obviously the accuracy needs to be 99%. So for each case, we do actually need to come up with a different approach.
Right. AI has been in the news so intensely in the last 3 months, especially because of ChatGPT and all these things happening way over at the other end of the industry. And I'm not expecting that people are going to run 175 billion parameter models on their sensors anytime soon. But when you look at what's happening in generative AI with things like DALL-E and with large language models like ChatGPT and Bard from Google and so forth, what are the lessons that you take away from that are relevant down here in the tinyML space?
It's the AI field is really enormous, and it's every time we meet the customers, I do feel that there definitely needs to be going through the learning curve to understand how vast this space is. What I see from the ChatGPT and other type of tools that we see in the market today, or the trend that we see, is that the trend in building the applications or building the solution is really now moving from solution and application development to solution and application assembly. So, going from, hard coding, coding, building the algorithm line by line to a new stage where now domain experts, even those people that don't have expertise in building AI applications, can simply use a tool to assemble and build their own applications. I think that's really what's going to change this adoption of AI applications in the field. So we see this no code or low code and no code trend as the big thing in the AI space as well. I mean, obviously in the software space, it's been there. This concept of low code and no code has been there for a long time, and new tools are coming out every day, allowing domain experts to build their own application. But even in AI, I think this trend is picking up fast, and I think that's really going to be the major trend and the way to have AI to be mass adopted in the field.
Yeah. I'm really curious to see what happens. And I think that's probably also a good time. It's a good time to prompt people to ask questions. There's a QA tool. So if you pop up some questions, we will try to answer some of them. In the meantime, what are the biggest effects that you see in what's happening with sensors? How are sensors changing that will affect what problems people get to take on? And what are the sensor types that you think are changing most dramatically right now? And when you look across, motion sensing and audio sensing, microphones, cameras, other kinds of sensors, what are the ones where you see really interesting things happen that will cause people to say, oh gosh, I can now do some entirely new application, or oh gosh, I now need ML to do.
Well, I think in terms of like the evolution of the sensors and hardwares, the fundamental the work that sensors do is still, I think, pretty much the same, but the packaging is definitely evolving, where now sensors can have its own intelligence. The small cores, processing cores that gets bundled with the sensor can now allow sensors to not just generate raw data, but to have its own intelligence. I think that's really the big change that we're seeing today. So, like the cores that some of the cores gets bundled into the sensor itself, or some of the cores are getting into microcontrollers and doing a lot of different type of machine learning processing on device, and that allows customers or the users to build applications that can do different things that they couldn't do before, like doing things with very small latency, with very small power consumption and very high accuracy. And that's really allowing them the freedom to build applications on the mobile devices or wearables and things like that, where previously was just simply not possible. So applications, I think the ideas are still need to be coming from the domain experts, but I think it's really giving them the flexibility that that designing AI applications for sensors now can be done on a single sensor or a very small package, instead of having to worry about all the connectivity and sending data and so on. So yeah, I think that's the big change that I saw in the recent years.
Yeah. Here's a question for you from Dale Hitt. Dale always asks pretty interesting questions. What is the path to getting large generative AI intelligence to run on tiny edge environments?
Okay. Well, building the AI tinyML application process is mostly similar to building AI applications that runs in the cloud. It needs to go through 2 extra steps, compressing the model and converting the model to C code so that you can use the compiler to compile it and make it run on the small silicon. So up to the stage where you're validating the model, doing data collection, data cleansing, and doing feature extraction and building the model. Up to this stage, it's the same as building the model that runs in the cloud. But there's that 2 extra steps at the end where you need to compress the model and compile it.
Yeah. Just as an aside, I think there are lots of people who look at these large language models and conclude they're way bigger than they need to be. That in fact, there are models that are merely 1 billion parameters that in specific respects work as well as the 175 billion parameter large language models, which supports your point that very often, inside a big model is a small model trying to get out. Particularly if you say, well, I don't have to handle every circumstance. I'm really interested in this one domain. And in fact, the existence of those large models sometimes puts them in the role of the teacher model. And you're essentially using them to train or to subset to do something smaller. And it means that I think we probably can aspire to taking certain dimensions of that kind of intelligence, whatever that means, and packing it down into these small models by applying it in the narrower domain that you find around a particular use case or a particular sensor. I also note that I think Apple has been extremely committed to this idea of privacy means at the edge. At the edge means figuring out how to put significant computing resources into rather small devices. Now, I wouldn't call this a tiny device yet, but it's a huge step from running these enormous models. And so I think that watching what Apple is doing is something of an interesting guide to what ultimately is possible when you're saying, well, now it needs to fit into, some tiny device that has a button battery or equivalent. So I think there is a lot of momentum in that direction, but it does mean picking and choosing what is the kind of functionality you actually want associated with some tiny gadget.
Yeah, I agree. When we think about AI, a lot of times, most of the people think about this like huge, the cybernet running in the cloud. But what we actually do need is having even a small sprinkle of intelligence on each sensor can really improve the user experience of certain things. Like our CTO Chris Harrison often use this analogy or the example to explain this, that when you look at like the toasters, the smart toasters, you don't actually need to have a screen on a toaster that communicates with the cloud and understands your voice and all, but you do want to have the toaster that can detect the right temperature and the humidity and build a tasty toast for you. And that may be a small, AI model that can do that, and that will, make your experience better. So when thinking about AI, we often think about, hey, even the incremental things can really change the experience. So look into the real needs, not looking at the whole concept of the big AI needing to be everywhere. Like, and of course, the big AIs do require a lot of computation power, and that increase the price as well.
There's another question here, and I think you'll have to choose your own interpretation of it. What is the expectation in the industry when you hire an engineer for tinyML?
Oh, wow. That's a big question, because I'm not actually involved in hiring in tinyML engineers. I leave that all to our engineering team. I mean, I'm not the expert in engineering at all, so it'll be stupid for me to pick the engineers. But I think most of the times we just look at the fundamentals. I think our engineering team is taking a lot of effort in going through the interviews with coding challenges, and there's multiple rounds of interviews just to make sure that they have the right fundamentals. I don't think you can. Maybe now it is possible to find engineers with tinyML experience, but obviously in 2012 when we started this, it was hard to find AI engineers or machine learning engineers.
Yeah, right. Of course, I think there's been an explosion of people who have some experience in ML, in part because there's such a wealth of training materials out there. But certainly in my experience, it's a relatively small fraction of those who have some experience who've actually done it all and built systems from scratch, and so everybody is sort of cobbling together, bringing together parts of the solution, and they're figuring it out. But given that technical communication is so good these days, there's so many places that you can fill in the gaps from, whether it's a vendor or a supplier or a meetup like tinyML community. There's just a lot of resources for people to build a more complete skill set. And certainly in my experience, even at Babel Labs and at Cisco and Silica, that you don't need people who have done it all. You need people who are smart, who understand some things about quantitative analysis, who can use the underlying tools. And it's often possible to go a long way with that approach. The unifying theme for me in a lot of ML is it's a highly analytical, statistical process that you have to go through, because in a sense, at the core of it is this idea: we do not program by writing lines of code. We program by collecting and labeling data. And so understanding the statistical characteristics of the data is the key to understanding what the behavior of the system is going to be.
Yeah, I agree. I'm not the best to answer that question, but anyway, our VP of machine learning will be at the tinyML summit, and he may be the best to give that answer, because he's the guy that's making the hiring decisions.
Yeah, well, it's great to talk with you, and you brought lots of insights about sort of how the business and the technology have evolved. And with that, thank you, and I'm going to hand the baton back to Evgeny for wrap up.
Thank you.
Yeah, I think thank you, Chris, and thank you, Sam. It's been really very insightful discussion. Just a very last question from me, Qeexo, and you and your team. You've been very successful in what you've been doing in the past 10 years or so. But what does it mean to be successful for you personally, Sam?
Well, dude, I would say that the thing that I feel most accomplished about is commercializing that application, FingerSense and YearSense. Basically commercializing tinyML solution in mass scale. That's a big accomplishment that I have, and I would view myself and the team successful when we reach that accomplishment again in this new field with AutoML in the industrial space. Because I think this challenge in commercial adoption in mass scale, that is actually very, very challenging. But when we reach that goal, it's very the feeling of accomplishment is you can't compare that to anything. So that will be my goal and my objective for the next step. Yeah.
And you're definitely on the way there, especially now with TDK partnership. Yeah, good luck.
Thank you.
And thank you again for joining today. It's been really, really great discussion. Yeah, thank you.
Thanks, Evgeny.
Thanks again.
Yeah. Yeah.
We would like to thank once again all our strategic partners and sponsors, and let me go one by one. So we'd like to thank our executive strategic partners, and specifically AgentPath, the leading development platform for HML. We would like to thank Qualcomm AI Research, advancing AI research to make efficient AI ubiquitous. Sentient, making AGI a reality. Also, I would like to highlight our platinum strategic partners. That is Renesas, is enabling the next generation of AI-powered solution that will revolutionize every industry sector. Sony. Thank you to our gold strategic partners. Analog devices, where what if becomes what is. We would like to highlight Arduino Pro, easily deploy your tinyML solutions with Arduino Pro. ARM AI, powering tinyML innovations. Inotera, that is our new sponsor, neuromorphic intelligence for the sensor age. Microsoft. SensiML, the right AGI tools can make or break your next smart IoT product. ST Microelectronics provides extensive solutions to make tiny machine learning easy. Synaptics, engineering exceptional experiences. Also, I would like to highlight our silver strategic partners and thank them to getting tinyML to the next level. That is iZip, Compass Marketing, as well as our new strategic partner, Green Waves Technologies, Grover-T AI, IBM, Imagimo, Nota AI, NXP, OctoML, Poland Technology, Qeexo, Schneider Electric, Silicon Labs, and TDK. That is together with Qeexo. So thank you very much, Sam, for being with us today. Thank you, Chris, for hosting the series. It was an amazing interview. And thank you to all of you who joined today's series, and hope to see you soon next month. Our next series will be on April 5th. So stay tuned and be connected. Thank you very much for your attention.